Hi Paimarats, welcome back to the continuation of our forest fires project. Remember that via the link in the description of the video, you can open exactly the same notebook I'm working on right here. From the first part of the solution, we managed to identify two countries, Portugal and Bosnia, which appeared in the intersection of our three sets. Countries with not low precipitations, not high temperature change, but still experiences lots of burnt forest. And that for us signifies potential problem with crime. Now we would like to compare all countries of the world. Europe is pretty small and thanks to the European Union integration quite homogeneous. Therefore, we need some additional measure or indicator according to which we are going to compare or categorize all countries of the world. It can be related to geography, climate, maybe more. We are going to pick developmental measure, and that is called GDP, Gross Domestic Product per capita. And this data I obtained from the World Bank, and I will exactly show you how. Old concepts, sometimes still appearing in public, divide the world on the developed one and developing, or rich north and poor south, or simply us versus them, one way or the other. Hans Rosling and his gapminder.org teaches us how obsolete this concept actually is. And you can check him and also the Gapminder project. Instead, Gapminder suggests that we can split countries in terms of wealth into 4 levels. It starts with people living under the level of extreme poverty, which is below $2 or $2.5 per day. We are going to use $2 a day. And then you simply always multiply by 4 to reach the next levels. So we end up with levels of $2, $8, and $32. More than $32 per day, and you are in the highest tier of the world in terms of wealth. And that is exactly what we are going to try to recreate here. Let's try to organize countries according to the GDP per capita and add it as a column to our table. GDP data can be accessed directly through the World Bank. So we call the data GDP, and then I use the VB API, and I can access some data and I can put them directly into data frame. And then the input arguments is the name of the data set, and in this particular one I can select which year I want to obtain the data, in this case for 2020. Conveniently enough, the GDP data and countries therein are identified by their ISO codes. So I rename the index to ISO, and then I have two tables where the countries are both identified by ISO codes. Therefore, I can merge the original DF with the GDP DF, and I can merge it according to the ISO column or index. And I will put it in the data frame which has the same name as before, DF. And finally, I will rename the GDP column, which has this awkward name as the dataset itself, to GDP per capita in dollars. Now again, we are going to check the top of our table. Our DF now contains one extra column, GDP per capita in dollars, and the meaning is the following. GDP is the total amount value of money which the country produces in a year. Therefore, you can imagine that it approximates the value which the people which work in the country earn in average if you distribute the money equally, and that's how much money they have per year to spend. Let's play with the GDP column a little bit further. So, we can ask ourselves how much money have disponible poorest 10% of countries for their people. First, from our original data frame, we need to select the GDP column. And then we can apply the quantile, as we already know how to do, quantile 0.1, because we want to identify 10 poorest countries. And we get back $840 approximately, but that's for a whole year. So if we want it per day, then we copy what we did above and we can divide by 365 and we get $2.3 a day. So the conclusion from now is that 10% of the countries have only disponible for their people approximately $2.3 per day, which means that they live really in the condition of extreme poverty. Now back to our GDP levels. We mentioned that the transitions between the levels are at $2, $8, and $32 per day. And we want to create a new column which would signify which level the country is at. So we can create a column right away, df, and I will call it GDP level, and I will set all the countries at level 4. And then I will go through all the countries again by the command location, that's row by row, and say that if the GDP per capita is lower than the boundary of the next level, so level 3 is below $32. So 365 times 32 is some number, and if the GDP per level is lower than that, then I want to set the GDP level value in the column to 1 less. In this case, level 3. And then I go one by one, level 2, level 1, and everything should be fine. And indeed, the table contains now GDP level column with numbers from 1 to 4. Again, repetition, how many countries do we have in our DF? We can write land DF and 120 countries. Unfortunately, even our World Bank data on GDP is incomplete, and we are going to need to remove the missing data. This is at the time when I'm working with the program because I interactively downloaded the data through the API. So you might get more updated data, and this is one of the main advantages of the API. If the third party really is taking care of the data and updating them, you can take advantage of it and use the most up-to-date data in your programs. Okay, so for leaving the rows with any missing data, we are going to use the method dropNA, and we want to do it in place again on our data frame. So we are dropping so-called not a number, none values, and then we again check the length of the data frame, and we get 116 countries. So 4 data values were missing and the rows were removed as a whole. Now we would like to confirm how many countries we have at each GDP level. And we can use a very useful pandas method called value counts, which needs to be called on the column again. So we will write our df, and then I write GDP level, and then value underscore counts. This will give me the counts ordered from the most counts to lowest counts on each of the levels. So value 3 countries, we have 41 of those. At level 4 we have 32, and down at level 1 we have 15. This is a proof that the division into 4 levels is absolutely valid. And fortunately, the countries on level 1 are less and less numerous over time. We have countries organized according to GDP now. We can work out the forest fire logic for each level separately. Let's start with level 1 countries. Yes, indeed, we are truly going to repeat the steps we did for the European countries, so you should be absolutely able to do it by yourself. First step is to identify and pick out from our data frame the countries which have the GDP level equal to 1. So df, and now GDP level, and condition is 2 equal signs equals to 1. So that's our data frame for level 1 countries. As for the high burning limit, we are going to select from level 1 countries, and our column is called fraction burned, and apply quantile 0.7. Then we are creating a data frame out of the L1, and then again df L1 fraction burn needs to be higher than this high burn limit. That's the data frame, and to make the set out of it is calling simply method set, and we want ISO codes, therefore index. Regarding the t change, we again pick level 1 countries and then ask for the quantile of t change column, quantile 0.7. After that, we create a data frame from L1 countries. Condition is that the FL1 and the t change needs to be lower than our t change limit. Finally, creating the set out of the not large t change and index. Cannot surprise you with the precipitation part. Precipitation limit, again from the L1 countries, and average precipitations, then quantile 0.5. After that, creating the data frame with the condition that L1 countries average precipitation values need to be higher than the press limit. And finally, creating the set out of the data frame, not low precipitations, again index. Run the final cell. Now we have 3 sets ready. We can test our intersection logic as before, just for 2 sets. High burning countries intersected with the ones where the temperature change is not very high. Set not large temperature change. We get the inter2, hopefully they are ISO codes, and we can use these ISO codes together with the location method, input it there, inter2, and we should get rows of our original table, which is Mali and Chad. Both on level 1, both with high burning area, not very low precipitations, and relatively low temperature change. Now we finally proceed with the intersection of all 3 sets, high burn, intersection with set not large temperature change, and chained on top of that intersection of set not low precipitations. Again, location method, I will just copy it from above and change to for free, and we are getting 0 output. 0 interception from our free set logic means that low precipitations can justify high burnt areas in both Mali and Chad. Let's visualize the relations between our sets using a Venn diagram as before. Method was called Venn3, and as a required argument it has a list of sets we want to actually plot. So set was called high burn, first one, second one set of not large temperature change, third one set not low precipitations. We can run the cell and we get pretty decent output, just the sets are named ABC, so we can add, as I had before, labels and some alpha level. The interception of 3 sets confirms our original solution, that it seems that no country really stands out, and highly burned areas in Mali and Chad can be justified by low precipitations. Please go ahead and complete the analysis for other levels. It is all in the commented notebook. I will just not prolong this video too much and scroll down to the overall conclusions. I hope that the conclusion is that you have learned a lot during this project, specifically about data analysis and the power of using pandas module. And we have also touched some real-world data. However, I want to point out that only combining them from different sources gave us some possible insight. And as life itself, this project is an open one. Let me know how to improve it. As always, in the end, I have prepared some direct questions for you. In the exercise, we have worked with the intersection of 3 sets, but there are other subsets in our Venn diagram. Can you retrieve them using different combinations of union and intersection methods? And what do they logically represent, and would they be of any interest for the UN Secretary? Missing data I already tried to point out during the exercise, I will skip that. Then number 3, in programming we have functions wherever some codes repeats too often. Can you identify such parts and can you try to create such functions to ease your life and save yourself from lots of writing? And constructing sets performing logical union and intersection methods is only one way. There was this artificial step when we created set out of a data frame. So can you try and find how to use pandas itself and pandas methods, which would allow us to do the same tasks? And you can refer to pandas manual here. Good job everyone, check some other projects, come back to me with questions, suggestions, whatever you need. Cheers!